Now, using the same population data of 80, 82, 85, 88, and 90, we draw the sample of size n equals 3 without replacement. It is easier always to assume these five numbers as the first five letters of English language. And when we talk about drawing sample of size 3 without replacement, this is definitely a representation of combination of three alphabets in alphabetical order out of the five available alphabets. So we will apply in the same way NCN formula. This time lowercase of n is 3 and 5C3 will give us 10. So now we'll list the samples in alphabetical order, that is making A, B, C, then A, B, D, then A, B, E. We have taken the first two alphabets as A and B and keep on changing the third one. Now, we'll keep the A fixed as a starting letter. We will now change the next letter to C instead of D, and then A, C, D is the order that we can follow. Then A, C, E. And similarly, A, D, E. Now starting with letter B, because we are now completed with the list starting from letter A or alphabet A. Therefore, starting with B, this is B, C, D, following order again. Then B, C, E. Then we have B, D, E. And the last one should be C, D, and E. So you can easily count the number of samples we have ended up with 10 samples. That's the formula 5C3 equals 10 gives us. Now changing the alphabets to the numbers, we can now list the samples of size 3 in numbers 80, 82, 85, 80, 82, 88, 80, 82, then 90, 80 with 85, then 88, 80 with 85, then 90, 80 with 88, and then 90. And then we start with 82, 82, 85 with 88, 82, 85 with 90, then 82, 88 with 90, and the last sample would be 85, 88, and 90. And this is how we can draw 10 samples. Now, we have to compute the mean of each sample. Just add all three numbers and then divide by 3. And we can write down this answer, even though this is coming up as 82.33333 with recurring decimal place. So we have to round this off as 82.33. Now, what we do, take the sample mean of the next sample, second sample, and that's 83.33. Then the mean of the next sample is 84. Then 80 with 85 and then 88 gives us the sample mean value of 84.33. Then 80 plus 85 plus 90 would give us the sample mean value of 85. Then 80 plus 88 and then 90 would give us the sample mean value of 86. This would again give us 85 as the sample mean value. Then 82 plus 85 plus 90 would give us the sample mean value of 85.67. This would give us 86.67 and this would give us 87.67 as the mean values. Now if we again start telling the occurrences of the sample mean values in the form of frequency, then we get 1, 1, 1, 1 frequency for first 4 sample mean values. Then 85 is occurring twice, therefore we cancel this second occurrence and we tally this frequency as 2 across 85. That's 1, 1, 1, and 1. Now converting or transforming these frequencies to the properties, again using the concept of relative frequency approximates probability. So 0.1, 0.1, 0.1, 0.1, 0.2, 0.1, 0.1, 0.1, 0.1, and this is making 1 in total. Now as the next step, because we are going to compute mu of x bar that has a formula summation x bar times p of x bar. So we need to multiply each mean value with its associated frequency, and that would give us 82.33, 83.33, 84, sorry, 8.233, not 82, and 8.333, 8.4, then 8.433, then this is 17.0, then 8.6, then 8.567, then 8.667, then 8.767, and when we add them all, very surprisingly, we'll end up with the same value 85. Now to get the variance of random variable x bar computed, following this formula sigma of x bar square, that tells us that first we need to compute the sum of x bar squared times p of x bar and then subtract from that summation x bar times p of x bar whole squared. So what we do, I am telling you the sum directly, you should be getting 7227.27 as the sum.